In this video, we're going to be using the rational zeros theorem to find all zeros of a polynomial. So our steps are to list the possible rational zeros theorem, and then use the factor theorem to find a zero. And we're going to plug in the zeros. So if we find a zero, then f of c should give us an answer of 0. Okay. So once you have a zero, use synthetic division with its factors to reduce the polynomial, and then find the remaining zeros by factoring or quadratic formula. Alright, so first let's start by using the rational zeros theorem, which says take all the factors of your last number, the constant, and divide by all the factors of your first number, which is the 7 here. So P over Q is how that usually is stated. Okay, so the factors of 4 are plus or minus 1, plus or minus 2, and plus or minus 4. And then the factors of 7 are plus or minus 1 and plus or minus 7. Okay, so what this means is that our possible rational zeros are plus or minus 1, that's 1 divided by 1, both positive and negative, plus or minus 2, plus or minus 4. Okay, so that's these three being divided by 1. And then we've got, let's see, 1 over 7, so plus or minus 1/7, plus or minus 2/7, and plus or minus 4/7. Okay, so if we have rational zeros, it's going to be on this list right here. You cannot have a rational zeros of this particular function that isn't on this list. Okay, and we are told that every one of the functions we're going to do today has at least one rational zero. Okay, so how we figure out the quickest way to figure out if we have a zero is to just plug them into the function. Okay, so pick one of these that you think might be a zero and just plug it into the function h. Okay, so if we plug in, let's choose this first one. Let's just use 1, x equals 1. So if you find h of 1, if you get 0 as your answer, then that's going to be a 0. Okay, so let's plug it in. So 7 times 1 cubed plus 9 times 1 squared minus 12 times 1 minus 4. Okay, so the 1's are all just going to go away. So this is 16 if we add these two together, and this is negative 16 if we add these two together. So you do get 0 as an answer. Okay, so we got lucky. The first try that we did was actually a 0, so that's nice. And since 1 is a 0, then we know that x minus 1 is a factor. Okay, and now we can use synthetic division to figure out what's left when we divide it by x minus 1. Okay, so synthetic division, I'm going to take this number and put it out front of the box. It's the opposite of this number, or this number. Okay, so we get a 7, 9, negative 12, and negative 4. Okay, those numbers came from the function here. Alright, so drop your first number, multiply, add, multiply, add, multiply, add to 0. Okay, if this doesn't turn out to be 0, then you did something wrong. Okay, so what this means is if we divide this function by x minus 1, what we get as an answer is 7x squared, 1 down from what it was, plus 16x plus 4. Okay, so that is, along with x minus 1, that's h of x. Okay, so this is the same thing as this. It's just partially factored now. So if I was to multiply all this stuff back out, I would be back to where we started right here. Okay. Now let's see if we can factor this to get the rest of the zeros. Okay. So if we multiply 7 times 4, we get 28. Two numbers that multiply to get 28 but add to get 16 are 14 and 2. Okay. So I'm going to put 7 in the beginning of both parentheses because that's how I factor. So 7x plus 2, 7x plus 14, and of course we've got the x minus 1. Now this, to take care of this, because 7x times 7x is not 7x squared, so On this one, you can see that they're both divisible by 7, so just go ahead and do that, and it takes care of things. So you get 7x plus 2, x plus 2, and x minus 1. And that's all equal to h of x. So we've factored this thing completely. Okay, and if you want to solve these, which we do, you set them equal to 0. So 7x plus 2 equals 0, gives x equals negative 2 over 7. X plus 2 equals 0, gives x equals negative 2. And then, of course, we already know this one. It's going to be 1. But we'll do it anyway. So x minus 1 equals 0, gives you x equals 1. Okay, so those are all three of the zeros for this. And notice that all three of these, 1, negative 2, and negative 2 over 7, are numbers on this list. Okay, here's the 2 over 7, here's the negative 2, and there's the 1. Okay, let's do another one. So on this one, the first thing that we want to do is find p over q, which is all the factors of negative 15, or just 15, divided by all the factors of 2. So let's see, plus or minus 1, these are the numbers that go into 15, plus or minus 3, plus or minus 5, and plus or minus 15, divided by the factors of 2, which is plus or minus 1, and plus or minus 2. Okay, so all of our factors, if you take all the divisions here, you get plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15, and then do the 2. So you also get plus or minus 1/2, plus or minus 3/2, plus or minus 5/2, and plus or minus 15/2. Okay, so we're going to try to figure out by trying some of these, and I usually try the whole numbers first because that's a lot easier to divide, but we're going to plug them in and see if we get zeros and answer. So let's just start with 1 again. So we plug in a 1, h of 1, is equal to 2 times 1 cubed minus 3 times 1 squared minus 32 times 1 minus 15. Okay, you can see pretty quickly that this is not going to it's not going to work out. You've got a lot of negative terms and not many positive ones. So let's see, what would that give you? This is negative 35, negative 50 plus 2, negative 48. Okay, so we can rule out the 1 as being 1. Okay, we could try the negative 1, but I don't think that one's going to work either. So let's try a 2. Let's see what happens when we put in 2. So 2 times 2 cubed minus 3 times 2 squared minus 32 times 2 minus 15. Okay, so that's equal to, let's see, this is 8 times 2 is 16. 4 times 3 is negative 12. Negative 64. And minus 15. Okay, so that one's also not going to work. It's just too many negatives going on here. Okay, so this is actually, we're just going to say that's not equal to 0. We don't need to do the calculation. We can see that it's not equal to 0. Okay, so since it's going to take, it looks like it's going to take a few more tries, I'm going to show you a little shortcut you can do if you have a TI 8384 calculator. Let's focus that. Okay, so I've typed in the function here into y equals, and what I can do is I can hit second table set, and I can go down to the independent variable and I can tell it to ask. Okay, that way when I go to table, I've already got some values plugged in here, but that's all right. Now I can just plug in some of these values, and I'm looking for the one that gives me 0 out. So I try 1 that gave me negative 42. I've got negative 48. So I typed in something wrong at some point. Let's see. Let's see if I typed it in correctly. No, I didn't. I put a negative here, or positive. It needs to be negative. Okay, so make sure you typed it in correctly. Then go to your table. And okay, so we plug in a 1, we get negative 48. That's fine. 2, which is one we tried, negative 75. We could try the negative 1. That doesn't work. Or negative 2. That doesn't work. 5. 5 gives us 0. So okay, there we go. So we found the one that works. So let's confirm ourselves. So we got h of 5. Supposedly that's going to give us 0. So 2 times 5 cubed minus 3 times 5 squared minus 32 times 5 minus 15. That should give me 0. Okay, so let's see, it's 125 times 2, that's 250. Let's see, this is 25 times negative 3, that's negative 75. Let's see, 32 times 5, I believe, is 160. Minus 160. And then minus 15. Okay, so if we combine all these together, let's see, that's going to be 235, negative 250. So that's 250 minus 250, and it does work as we knew it would because we did it in the calculator. Okay, so if this is a 0, that means that x minus 5 is a factor. Okay, so if I found the zeros, I also found the factor. Okay, now I can use this. I can either use long division or synthetic division to figure out to make this fully factorable. Okay, so I'm going to put a 5 out front the house. I'm doing synthetic division here. Put the coefficients inside. Okay, drop your first term. Multiply, add, multiply, add, multiply, and then add. Okay, so that works. You get 0 as an answer. Okay, so we know that it's a factor, and we also know that what's left when we divide h of x by x minus 5, we get 2x squared plus 7x plus 3. Okay, so that's h of x. All right, now we need to figure out how to find the other zeros. The easiest way is to do factoring, but the factoring doesn't always work, so let's see if it does this time. Okay, so we multiply those two, we get 6. Two things that multiply to 6 but add to 7, that's 1 and 6, so it does work. Okay, so this factors into, here's the x minus 5, and then 2x plus 1, 2x plus 6. We have to take care of this one. Okay, divide them both by 2. Okay, so you get x minus 5, 2x plus 1, and x plus 3. Okay, and these give you 0, so if x equals 5, we're setting each one of them equal to 0. X equals negative half, and x equals negative 3. Okay, so those are the zeros, and that's how you find it.